Hi guys, today I'm going to present about distribution system, and this is the introduction. Distribution consists of three major parts, with is feeders, distributor and service main. For feeder, it is a conductor that connects the substation to the distributed area. And for the distributor is a conductor from which tapping are taken. So the distributor point is A to B, B to C and C to D. And for the service main is a small cable which connects the distributor to the consumer. For the next subtopic, I'm going to present about the classification of distribution system. There are two types of distribution system, which is AC distribution and DC distribution. But nowadays, AC distribution is commonly used because it is used widely, as it alternate voltage can be changed using transformer. And the transformer make it possible to utilize high voltage at safe potential. So the AC distribution was divided by two parts, which is primary distribution and secondary distribution. For the primary distribution, the voltage is stepped down to a lower level. It is the portion of the power network between distribution substation and the utilization transformer. The delivery point of electric power in large industrial. The voltage used are 11 kilovolt, 6.6 kilovolt and 3.3 kilovolt. All of this is carried out by three-phase, three-wire system. For the secondary distribution, the portion of the power network between the primary feeder and the utilization equipment. It is consists of also step-down transformer and secondary circuit of utilization voltage level. Residential secondary system are mostly single phase, but commercial and industrial system generally use three-phase. Next, I'm going to explain the types of distribution system. Firstly, the radial feeder system. Second, the ring or loop feeder system. And the last one is interconnected or network distribution system. For the radial feeder system, most power distribution systems are designed to be radial and to have only one part between each customer and substation. The radial system is employed only when power is generated at low voltage at the end substation is located at the center of the load. The advantages of the radial feeder system are simplest distribution circuit and lowest initial cost. For the disadvantages are the end of the distributor nearest to the feeder will be heavily loaded, and the consumer at the distant end would be subjected to the serious voltage fluctuation. However, radial feeder systems are less reliable than loop or network system because there is only one path between substation and the customer. Thus, if any element along this path fail, a loss of power delivery results. Generally, when such a failure occurs, a repair group is dispatched to re-switch temporarily the radial pattern network, transferring the interrupt customer onto another feeder until the damaged element can be repaired. For the ring or loop feeder system, it has two paths between the power sources, which is substation, service transformers, and each customer. In this system, the primary of distribution transformer from a loop. The loop circuit starts from the substation bus bar, makes a loop through the area to be served and returned to the substation. In terms of complexity, a loop feeder system is only slightly more complicated than a radial system. Power usually flows out from both sides towards the middle, and in all cases can take only of two routes. Voltage drop, sizing and protection engineering are only slightly more complicated than for the radial system. For the advantages, firstly, less voltage fluctuation at consumer terminals. Second, the system is more reliable because each distributor is fed by two feeders. And lastly, with carefully planned design, any failures will result in minimal interruption to the consumer. For the last type, it is the interconnected or network distribution system. When the feeder ring connected by two or more generating substations or substations is called interconnected system. Consider load A and load B through the transformer. If the two systems are not connected, each can be operated independently at its own frequency, and one disturbance on one does not affect the others. For the system advantages are: improve the overall stability. Systems that are interconnected have greater reserve power than their combined resources than a system working in isolation. Next, provide better continuity of service. If one of the generating stations should break down or has to be closed for annual inspection and repair, energy could be supplied by remaining station. And lastly, it is more economical. When several regions are interconnected in the form of a grid, the load can be shared among the various generating stations so that the overall operating cost is minimized.